Good day. I'm Terry Chauvin with Cornerstone Inspection, and we're coming to you today to demonstrate an invention that we have that captures defects on the fitting side of pipe to fitting welds. Right now, the industry has two options when it comes to pipe to fitting welds. You can either X-ray it, or you can do single side phase array. The problem with RT, which we're going to demonstrate today, is this fabrication piece was made with 12 defects, 6 that went undetected by X-ray, and those 6 defects were sidewall non-fusion. The phase array is great at catching sidewall non-fusion. However, on the fitting side, because the beam runs parallel with the defect or the indication, often goes undetected. So with half of the weld being uninspected or not correctly inspected, there's a potential for a lot of flawed welds to be put in service. So that led us to come up with this TOF setup that has multi-pivoting axles on it and allows us to scan pipe to fitting welds, whether it's a convex, concave, or a flange. We're able to maintain contact and get true 100% coverage. And we do this in addition to the phase array that current is on being used by the industry. So I'm going to go ahead and hand this off to Kyle, and he's going to do a scan, and we're going to do an evaluation. And the evaluation is going to be on a flaw that's on the flange side. It's defect 1, I believe, in slide 4 of the PowerPoint that we sent y'all. So you can go ahead and refer that to the legend in the top right corner of slide 4, and we'll go ahead and scan this, and he could size it for you.
Hello guys, I'm Kyle Wiesner with Cornerstone. Today I'm going to be doing the scan and the data portion of the video.
This, by the way, is a 6-inch Schedule 80 pipe. We were actually quite surprised that RT didn't pick up the sidewall non-fusion. Another advantage of having the TOF, in addition to the phase array, is for porosity and your cylindrical defects. Phase array sometimes has a little difficulty picking up porosity and sizing it. TOF is by adding that component to your scan plan, really enhances your inspection. It also gives you 2 methods that you can compare against each other, which will reduce your false calls.
Alright, now this weld had 4 defects in it. Now as you can see on our top data here, we actually have a defect here, 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 and here. And this defect is just an overlap of this first one here. And now we're going to take it to the sizing of this video.
You want to break down the TOF image so they could
So now what you're looking at here, you have our TOF data, and this is basically your surface. This is your back wall. Everything here in between is going to be the volume of your weld. And as you can see, we have our defects here again. We're going to go ahead and size that.
Once again, this is defect number 1. This was the one that RT missed, as well as phase array. So that's what we want to show here, that not only can we detect the defects on the far side, on the fitting side of the weld. We want to show how precise we can be in our actual height and length sizing.
Now we're going to go ahead and do the height sizing first. Going to move our data cursor over the defect that we want to size. Going to zoom in. Now the way TOF works, it works from tip to fraction. So we're actually going to be sizing from our top tip of our flaw and the bottom tip of our flaw. And we'll place the cursor on the top tip now. We're going to scroll over to our bottom tip. Now as you can see, this is our height right here at a 0.072. And now we'll go ahead and do the length.
While he's doing the length, on the last slide of the PowerPoint that we emailed you, it shows the RT film from this particular weld, as well as the phase array data. Normally there's a color palette with the phase array data. We just removed that just to keep it apples to apples, so it shades of gray. And then the third row is the TOF image. So you can see that defect number 1 and defect number 2 in this flange weld in the RT film. You can see where the defects were supposed to be, I should say indications. And then in the phase array data, you can see where defect or indication number 1 was missed. And you can see how clearly the TOF was able to pick that up in the TOF scan.
Alright, now what we're looking at here, we placed our cursors on both sides, and we have a length of 0.483.
In the legend on, I believe it's slide 4, the top right, this is indication number 1. This is the sidewall non-fusion on the flange side, and if I'm not mistaken, I believe the length was 515 and the height was 050. So that shows right there how accurate this method is, and this particular scanner goes down to 4.5 inch, but we're actually maybe a month away from designing one that goes all the way down to 2 inch, so that it will accommodate every need that you may have. This is good for any pipe to fitting weld that you may have, and we would love to come and give you a live demonstration and give you more information. One other thing that we want to add here, go ahead Kyle, why don't you show them that.
Okay, what you're looking at down here is our TOF data, and we have some phase array data here. As you can see on our phase array, we completely missed that indication, but our TOF plain as day right there. So we just wanted to point that out, show you guys how the phase array missed it and picked it up with the TOF.
In closing, I want to add that our guys all API certified for QUTE or QUPA and QUPA, I should say, as well as a PCN level 2 in TOF. So our guys come industry certified. We don't have any TC1A. We try to stay with the industry standard. We believe you as a client deserve that. So we hope that we've shown you enough here that if you want to get in touch with us, the email address that we sent you with this link, just return it, and we look forward to hearing from you. Have a blessed day.